Hello, everyone. Robert Saunders here, and today I wanted to showcase yet another storage resiliency for Apex Block Storage demo, but this time Saeed and I did it over in Azure. It's very cool. Of course, we use SQL Server, again, one of the tools I know and love. And myself, Robert Saunders, I'm technical staff. I work as part of our technical engineering group here inside of Dell. And Saeed, you want to introduce yourself?
Hi, I'm Saeed Abrar, and I work with the solution engineering with PowerFlex.
Excellent.
And thanks, Rob, for inviting me here.
Yeah, this is going to be fun. So first off, let's kick it off here. And our simulation architecture, to rehash a little bit about what Dell Apex Block Storage is when it's running in the cloud, it's separate instances. We call them the SDS, the storage nodes. And for this simulation architecture, Saeed wired up the 3 different AZs, each with 2 SDSs per AZ, but that it's a single cluster that's, call it maybe peanut butter spread across all 3 of those availability zones. That's what provides our resiliency. And as part of our simulation today, or I said 3, as part of our simulation, we're going to stop the instances in one single AZ right there to simulate an AZ failure. Because yes, it can happen in the cloud, but you're going to see SQL Server continue to run it and not even really aware of what's going on, which is super cool and very powerful. Any thoughts, Saeed?
So the most important thing here is we have configured something known as fault sets in the Dell Apex block storage, so that even though if AZ goes down, still the application is unaware and it will be serving the purpose.
Yep. Good point, Saeed. Fault sets are synonymous with AZs, right? Those are kind of the same nomenclature, but different technologies. Yep, good point. Thank you. Well, let's kick it off here and let's kind of move through the recording that we made of the lab environment. First off, of course, SQL Server 2022. One of the products I know and love. There's HammerDB. Now, I'm not looking for performance here. What I'm looking for, again, is storage resiliency, although those numbers aren't bad. But right now, we'll just show work being done. If you're familiar with HammerDB, orders are being generated. We see in the middle there, TPMs logging. We see SSMS, SQL Server Management Studio logging work. All kind of standard stuff there, just showing workloads that are running. Now here, we're in the PowerFlex Manager interface, and we also see we're starting to log some work there with performance and latency just got started, so the graph's just kind of building itself out. More on this here in a little bit. When we do our failures, you'll see quite a lot of logging in a really good way inside of PowerFlex Manager. So drilling into the PowerFlex system, we have our system details. We see our IP addresses, our primary and secondary for our MDM cluster. Now those IP addresses are what is represented up in Azure. So we do present that back to the PowerFlex management system when it's running as Apex Block Storage. You can drill into our storage there. We see our protection domain. We have a single protection domain. And the nodes, we see the SDS, the storage nodes, there they are again. And there's the fault sets that Saeed and I were talking about, AZ1, AZ2, AZ3. And then the SDC, the storage data client, that is the consumer, that is the SQL server that's consuming the storage from the SDS. Any thoughts, Saeed?
Yeah, on the SDC is where this is installed on SQL Server. So it's going to consume all the storage from the SDSs. So SDC is our compute.
Yep. Yep. There's those storage instances that we showed in the architecture earlier. And of course, yes, what we just talked about, SDC is the SQL Server. There's the volumes. Pretty standard stuff for SQL Server, data, log, backups. And those actually equate, because we're on the same box here on the SQL Server, we're doing all the work to minimize flipping around. There's, of course, some of the volumes, data and log. Pretty standard if you're a SQL Server guy. Flip back to PowerFlex Manager and we see work. Back to HammerDB, we still see work, but let's go over to the Azure portal. So inside the Azure portal, Saeed deployed all the machines here. We can look at the details. Remember, we're looking at one of the PowerFlex storage nodes. I'm sorry, one of the Apex block storage nodes deployed into Azure. If you're familiar with the Azure portal, you're very familiar with what you can browse around and look through there. So now we're ready to start the simulation. We have, actually, Saeed, you deployed the L32s here as part of the deployment, which is great. So we're going to pick 0 and 3, which are part of 1AZ, and we're going to shut them down to simulate the failure. And then we're going to jump back over to HammerDB and make sure SQL Server is still running, which is backended by Apex Block Storage. So quickly here through the portal, we'll stop both of those instances. Again, if you're familiar with the Azure portal, very easy to do. Get some notifications. Takes just a little bit of time to shut down those instances, not long. Now we see here, there is a slight dip. Exactly. I mean, we expected this because we just kind of disturbed the force, let's say, of the storage, right? For SQL Server. However, the workload remains resilient. And then we have the rebuild to reprotect that's taken the priority. So Saeed, any thoughts here?
So the moment when we simulated a failure, at this point, the application is unaware. And in the back end, the system is going to send alerts and error messages stating the SDS is offline or down. At the same time, the self-healing of the storage starts. So it starts to rebuild the rebuild operation to preserve the data protection.
Because we need to make sure we have 2 copies of the data everywhere, right? Which is, that's part of the resiliency inside of Apex Block Storage. Super cool technology. So let's watch this here continue on. We see the dip there that HammerDB kind of recorded. Jump back over to PowerFlex Manager. And this is, Saeed, we were talking earlier where it does say rebalance, but in the background, the technical representation is actually a rebuild. Do you want to elaborate a little bit?
So as soon as it understands there is a failure, so rebuild is an operation which starts and it is trying to preserve the data.
Yeah. So now we take a look at PowerFlex there, and you can see kind of right there, you see a little bit of a dip. So we logged it all. We logged a little bit in the latency. However, SQL Server kept running. If you're familiar with HammerDB, there we are. Look at the TPMs are coming back. So we took a little bit of time to rebuild, and now our TPMs are coming right back up to where they were. This time we're running on 4 storage nodes instead of 6. Orders are still being generated via SQL Server. TPMs are still running. And of course, we're still logging inside of PowerFlex Manager for Apex Block Storage. That work is still being generated. Now, this is cool. We see they're stopped. Now what I do here is we're going to bring them back. We're going to bring these devices back online. We're going to add the SDSs back, and we're going to add the devices back for those SDSs, all while SQL Server is still running. So we're going to start those same instances now, highlight them both. Again, Azure, just start them up, super easy. Takes just a little bit of time to spin them up. So we've started them up, Saeed, but there's a few things we need to do with the SDSs now, correct?
That's right. For this demo, what we have gone with is the NVMe ephemeral drives. So you have 2 options. One, you can go with the drives which keeps the data. But for the performance sake, we have gone with ephemeral. So once you stop, your data is wiped out. So you need to reconfigure them back in the back end to gain back all the capacity.
Right. Need to add those devices back, right, for the SDSs. So let's show that here. Devices. I sped this up a little bit just because it's a lot of copy and paste and checking boxes. So you see the 4 there that say NA 000 through 003. Check all those for both of the SDSs and remove them. First we have to remove them, then we have to add them back.
And it's super easy.
Yep, super easy. It is super easy through PowerFlex Manager. Absolutely it is. Now, we're going to add those back. We're going to add the devices back. You see the capacity there on 2 and 4 is 0. So we need to add the storage devices back to the cluster. Now, I did speed this up in the interest of time, which is perfectly fine. 4 per instance, I'll add back here real quick. And remember, we're doing this storage admin activity all at the same time SQL Server is still running. We've never, you can see over with Activity Monitor over there, SQL Server is still logging work. We'll jump back to HammerDB in a second. But I like this demo because storage admin's doing work and SQL Server is, let's say, blissfully unaware. There we go. Again, a slight dip because we now where the Saeed, the rebuild or the rebalance is now moving the blocks back out to the new instances that are back online, correct?
That's right.
Yep.
So rebalance operation is good. What it does is it increases the availability and capacity and adds the performance back. So you are adding more storage onto the system.
Again, all while SQL Server is still running, which I think is very cool. That's a fun little part. And then I'll look at our TPMs. They're back actually even above what they were before. So this is cool here in PowerFlex Manager. Again, we kind of see the whole demo right there in the overall performance. We see where we took away, we see where we added them back, and then we see that final little dip there right on the edge where performance is actually coming back and a little better than it was before, which is pretty interesting. Now we're back to the steady state. There we are. That's a very cool demo. I'd love to show that. Pretty awesome. Any last words or thoughts there, Saeed? It's a very cool showcase.
I truly believe, and for a mission critical data, once in cloud, if you have properly configured fault sets, even though your whole AZ goes down, your data is protected.
Yep.
And the application would never ever you would see any disconnects or downtime there.
Yeah, the resiliency, if you're going to measure in 9s, you're talking maybe 5, maybe even 6, depending how you're doing it. It's super cool. Awesome. Well, thank you, Saeed. I love doing these with you. I really appreciate your time, and we'll get some more done here in short order, I'm sure. Thanks again. Appreciate it.
Thanks, Rob.